All right, for our last example, we're going to look at trigonometric ratios to find other ones. So here, if the sine of theta is 5 over 6, label the triangle to find the other 5 trig ratios. Put theta in one of the acute angles before labeling the sides. So here, I'm just going to assume here's theta. So if the sine of theta is 5 over 6, well, first of all, here is my opposite side. So I'm going to write O and then A and then H for hypotenuse. So here in this ratio, the sine is so opposite over hypotenuse. So the opposite is 5 and the hypotenuse is 6. So what I'm going to do is use the Pythagorean theorem to solve for what this adjacent side would be. So I do know that we would have 5 squared plus, I'm going to write b squared equals 6 squared. Well, 5 squared, 5 times 5 is 25, plus b squared equals 6 squared, 6 times 6, 36. So now I'm going to solve for b by subtracting 25 from both sides. And I get b squared is 36 minus 25, which is 9. And then taking the square root of 9 is 3. So now what I'm going to do is fill in the ratios. So we have sine of theta, opposite over hypotenuse. We're given that. It's 5 over 6. Cosine theta, adjacent over hypotenuse. So in looking at this side, the adjacent is 3 over the hypotenuse is 6. And then I can reduce 3 over 6 to 1/2. And then for the tangent of theta, TOA, so opposite over adjacent for that one. So O over A, and then that would be 5 over 3. Let me kind of just separate that out here. So 5 over 3. And then for cosecant, secant, and cotangent, again, it's just the inverse of those. So the hypotenuse over the opposite, hypotenuse over adjacent, and adjacent over opposite. And then what we can do is just take the inverse of all of those. So the cosecant of theta is the hypotenuse over the opposite. So the hypotenuse there is 6, and then the opposite is 5. So we have 6 over 5. And then as we look at the secant, again, that's hypotenuse over adjacent. So I'm looking at here, we have 6 and then over 3, which 6 over 3 reduces to 2 over 1, or just 2. And then for cotangent, cotangent is adjacent over opposite. So in looking at this, we would have the adjacent is 3 and the opposite is 5. So it'd be 3 over 5. So now, as I look into part B, if the secant of theta is 24 over 7, label the triangle to find the tangent of theta, and we're going to find all of the ratios. So I'm going to call this side theta. And then again, we have the secant is 24 over 7. And then remember, I did the Choshikow, so the cotangent is the hypotenuse over opposite, which we don't need. But for the secant, it's the adjacent, the hypotenuse over the adjacent. So this is what we're looking at. So the hypotenuse over the adjacent is 24 over 7. So if we have theta here, I can see that the hypotenuse is going to be 24. And then if theta is here, there's my opposite and here's my adjacent. So this side is going to be 7. So now you need to use the Pythagorean theorem to finish off the missing side. So I'm going to put in there 7 squared, and then I'm going to call this b. So plus b squared is equal to 24 squared. Pardon that, that's sloppy. That looks a little messy. 7 squared, I can do 7 times 7 is 49. Plus b squared equals, and then I'm going to use technology for 24 squared, and then just do 24 and then squared. And I got 576. So now I'm going to solve for b. So subtract 49 from both sides. And then I get b squared is equal to 576 minus 49 is 527. Then I'm going to take the square root of both sides. So b is equal to the square root of 527. Then I'm just going to check that by going, all right, well, 7 squared plus the square root of 527 squared. And then that gives me 576. If I take the square root there, I should get 24. Oops. So I need this square root of 576. And I got 24. So my math is good there, and I just need to fill in my ratios. So again, from theta, here is my opposite, adjacent, and hypotenuse. So sine of theta is opposite over hypotenuse. So filling this in, I have the square root of 527 over 24. And then for cosine, we have adjacent over hypotenuse. So the adjacent is 7 and then over 24. And then for tangent, we have OA, so opposite over adjacent. So we have the square root of 527 over 7. And then cosecant, remember, hypotenuse over adjacent. So the hypotenuse is 24 over, hypotenuse over opposite. So the hypotenuse is 24 over the opposite of theta is the square root of 527. Which again, we could have just did the inverse of that ratio. And then here for the secant, we have so hypotenuse over adjacent, or here would be the hypotenuse is 24, and then the adjacent here is 7. So that's 24 over 7. And then for the cotangent, we have cow, so adjacent over adjacent over opposite. So we have here the adjacent is 7, and then the opposite is over the square root of 527.